Good evening, everyone. Good evening, everyone. Hello. How is everyone? Good evening. Mr. Panda, good evening. Hello. Good evening, everyone. Good evening. I hope you all are doing well, right? Good evening, Ketana. Good evening. I'm also doing very well, Good evening, everyone. So I hope you guys have enjoyed the last class. Hi, Harshita. Hi. Hello, everyone. So I hope you guys have learned something in the last class, right? How to calculate the oxidation number, right? So in the last class, we saw that how to calculate the oxidation number and everything, X method, yes. So from that, Cr2O5 was the last problem, yes. Okay, so we'll start with one problem. Okay, calculate the oxidation number of okay, we'll have two problems. Calculate the oxidation number of, let us say, which compound? Okay, calculate the oxidation number of phosphorus in H3PO4. Okay, oxidation number of H3PO4. And in one, you calculate the oxidation number of, let us say, H2SO8. Calculate the oxidation number of sulfur. Calculate the oxidation number of phosphorus and calculate the oxidation number of sulfur in these two compounds. Go for it. Calculate the oxidation number. Very good. +5. Very good. What about sulfur? H2SO8. H2SO8. In this one, it is 5, right? Very good, all of you. So phosphorus being X, this is hydrogen, which is +1, so 3, and this is +4 of -2, and total charge is equal to 0. So X is equal to +5. Very good, right? What is the oxidation number of sulfur? +14 we are getting, +14. Oh, +14. Is it possible to have +14? If you remember, what are the electronic configuration of sulfur? Valence electronic configuration of sulfur? Oxygen family, right? Oxygen family. So oxygen ka configuration is 2s2, 2p4. Third period, same configuration. Thus it is third period. So this is 3s2, 3p4. So number of valence electrons are 6. Number of valence electrons are 6. Because the number of valence electrons are 6, 5 and 7. 7 to beta ji possible hi nahi hoga. 7 is not possible. So for oxygen it is 2s2, 2p4, and for sulfur it will be 3s2, 3p4. 3s2 and 3p4. So number of valence electrons are 6. So maximum oxidation state +6, and minimum oxidation state, what is that? 6 minus 8. So this was the minimum oxidation number, and this is the maximum oxidation number. This is the minimum one. The minimum oxidation number possible is -2. Maximum oxidation number is +6. So these are the oxidation numbers we can have. It will be 6. How it will be 6? Of course, it will be max. It can't go beyond that. +5 and +6. Very good, Solo. Whatever your name is. But how come we are getting +6? If you go by the X method, in H2SO8, if we go by the X method, the value is +14. I hope you have corrected. +7. So this is +2 plus 2x plus 8 into oxygen carries -2 is equal to 0. Now 2x minus 16 plus 2, 14. So this is equal to 14. Your X comes out to be plus 7, which is not possible. So whenever we calculate the oxidation number, you cross check it once. Whenever you calculate the oxidation number, you cross check. How to cross check? For any given element, check its valence configuration. So maximum oxidation number is the valence electrons, and minimum oxidation number is valence electrons minus 8. So you always check like this, and then you see how to go about it. Okay. So in this particular case, it comes out to be plus 7. That means the oxidation state we are getting is actually more than maximum oxidation state. Please remember, this will help you in higher classes, in upcoming 11th preparation, JEE preparation. So whenever you have oxidation state more than maximum oxidation state, that means one thing is very clear, that all the oxygens are not present in -2. If all the oxygens are in -2, definitely the oxidation state should be plus 7. That is what we have seen in CrO5. The same question we saw in CrO5. In case of CrO5, the oxidation number comes out to be plus 10, right? But the maximum electron is 6. So maximum oxidation number is plus 6. So all the oxygens were not present. Why 8 minus 2? Beta jo oxygen ke upar charge is -2. Oxygen ke upar charge is -2, so 8 into -2. But if it is true, if -2 is on all the oxygens, then the X should be plus 7, which is not true, right? So if you remember CrO5 ka structure, what is CrO5 ka structure? Chromium, oxygen, and oxygen, and this is double bond O. So you see, this is -1 and -1. So whenever we get this kind of bond, which is oxygen bond, this is called as peroxy linkage. Peroxy, oxy nahi, oxide linkage nahi, peroxide linkage, which is called as peroxy linkage, linkage. Okay, this is called as peroxy linkage. If you remember, in the last class we saw hydrogen peroxide, isn't it? Hydrogen peroxide. So if you look at the structure of hydrogen peroxide, what is the oxidation number? -1 and -1. So in this case, oxygen contains oxidation number -1, and this particular linkage is called as peroxide linkage. So whenever we go beyond the natural tendency of the oxidation number, beyond the maximum oxidation number, that means it is confirmed that there must be peroxy linkage. There must be what, Bulbeta? Peroxy linkage. What is peroxy linkage? Hydrogen peroxide. Just remember the name. No need to memorize. Remember hydrogen peroxide. What is that? H2O2. So in that case, oxygen will have -1 oxidation number rather than -2. You see, here also, because in chromium, the maximum possible was plus 6 and we were going to plus 10, that means there will be number of peroxy linkage. There will be number of peroxy linkage. So you see how we have managed. So we were having 4 extra plus, right? That means how to remove that 4 extra plus? All the 4 oxygens, which will actually, if you go for the oxygen, -2. 4 oxygen means what? -8. So I want to have only -4, right? Because we are getting extra 4. So what to do? For 4 oxygen atoms, make it single, O-. How to do that? Form the peroxy linkage. To remove extra plus 4, we have to make 4 oxygen, not -2, but -1, so that it is not -8, it is actually -4. समझ आ रहा है? So that will be removed. So how many peroxide linkage we have? 2 peroxide linkage, oxygen linkage. So this particular linkage is known as peroxide linkage. Now, you see, in case of H2SO8, because we are getting more than plus 6, that means it is must, there will be at least 1 peroxide linkage. Let me draw the structure of the compound. So this structure is sulfur, oxygen, sulfur and sulfur like this. And then we are having double bond, sulfur, oxygen, OH, and S double bond O, OH. So this is the structure of the compound. H2SO8. Now if you see, the oxidation number is very good. देखो, this oxygen minus 1 single bond, this oxygen minus 1 single bond, this oxygen minus 2 and this oxygen minus 2. So overall what is the charge coming? Overall what is the charge coming? What is the charge coming? Minus 2, 2 to 4 plus 6. Similarly here also charge will appear as 6. So both sulfurs are having plus 6 and plus 6 charge. Both sulfurs are having plus 6 charge. समझ आ रहा है? Because all the side atoms are having minus 6 combined, so this will be plus 6. So whenever we go beyond the maximum oxidation number, it is confirmed that there must be one peroxide linkage. There must be one peroxide linkage. Okay. According to the charge you can manage. Okay. समझ आया सबको? Is it clear to everyone? Thumbs up दो. Is it clear to everyone? Give me बेटा जी. Is it clear to everyone? All of you? समझ आया this concept? Okay. Nice. So now we are coming to the redox reactions. I can give you more question to solve. Abhi I'll come again, beta. Don't worry. Abhi I'll come again. Abhi I have so many problem to solve. I'll come again to the calculation of oxidation number. For now, I'll explain. Swapna, I'll explain again. Don't worry. Let us begin with the types of redox reaction. We will come to it again. Okay. After a few minutes, we'll come to it again. Okay. So types of redox reaction. So what is redox reaction? In the case of redox reaction, there is reduction and oxidation happening simultaneously. Now look into this. Combination reaction. So we are dealing with the types of redox reaction. How many types of redox reaction do we have? Okay, let us start with this. Sulfur. If you look, this reaction is sulfur plus oxygen giving sulfur dioxide. Right? Now, is it a redox reaction? That is the question we are having. Combination. If I combine two elements and a new compound is being formed, and if the reduction and oxidation both have happened simultaneously, that is called as combination redox reaction. Okay, let us see. Sulfur oxidation number 0, oxygen oxidation number 0. You look at sulfur. Sulfur, what is the oxidation number of sulfur in this compound? I hope all of you know, minus 2 into 2 minus 4. So this is plus 4. See, plus 4, right? Because it is plus 4, it is having no problem. Right? All the oxygen will be in oxide form. Because it is not going beyond its original oxidation, maximum oxidation number. Right? Sulfur goes from 0 to plus 4 and oxygen goes from 0 to bolo beta ji, minus 2. What happened? Oxidation happened as well as reduction happened. Now, we have to write the half cell reactions. How to write the half cell reaction? This is a full cell reaction. Half cell means I have to write oxidation and I have to write reduction. Okay. So let us write oxidation and reduction and let's see what will happen. So in oxidation reaction, dekho beta ji, sulfur goes to sulfur 4 plus, right? Sulfur to 4 plus. So how many electrons are lost? 4 electrons are lost. Sulfur goes from sulfur to sulfur 4 plus, 4 electrons are lost. In this case, you look at the oxygen. How many oxygen? 2 oxygens, right? So this is O double bond O. Right? So this oxygen oxidation number 0, this can be 0 because there is no electronegativity ka difference, and we know that if there is no electronegativity ka difference, oxidation number will be 0. Reduction. So each oxygen will gain 2 electron. So each oxygen will become minus 2. Matlab this oxygen will gain 2 electron as well as this oxygen will gain 2 electron. So how many electrons are needed? 4 electrons. With 4 electrons, this will become what, bolo beta ji? O. Bolo. O. Actually, we can write 2O2 minus. 2 moles of oxygen which are having minus 2. Now, if I add the reaction, 4 electron cancel. What is the definition of half cell? In half cell reaction, we always have presence of electron. So what is the full cell reaction which don't have electron in the reaction? So S4 plus and 2 oxygen carrying minus 2 charge. If you combine these two, तो क्या बन जाएगा बोलो बेटा जी? SO2, which is a neutral compound because minus 2 minus 4 and plus 4. So this is a neutral compound. This is called as a full cell reaction. Now, I am going to introduce a new term which is called as oxidizing agent and reducing agent. Listen very, very carefully, beta ji. I am going to describe a new concept which is called as oxidizing agent and reducing agent. Listen very, very carefully. What is oxidizing agent and reducing agent? Oxidizing agent, which is also known as oxidizing agent. Aisa agent, what is oxidizing? The term itself suggests oxidizing agent means an agent which can oxidize somebody. Which can oxidize somebody. If it has to oxidize, let us say that there is an element, it has to oxidize somebody. If this element has to oxidize, that means what it has to do? Let me think. Sir, I want to oxidize somebody. If I want to oxidize, that means that element will lose electron because that will go under the oxidation. For example, let us say A wants to oxidize B. A wants to oxidize what? Bolo beta ji? B. If A wants to oxidize B, that means B will lose electrons because what will happen? B का oxidation. What will happen? B का oxidation. अगर मान लो B oxidize हुआ, so B2 plus let us say 2 electron. Hypothetically, I am taking some values. So A is oxidizing B, in which B has been converted to 2 plus 2 electron. Now what will happen to this electron? Now this electron has to be accepted by A. There is no other way. ये electron हवा में तो जाएगा नहीं. It is not going into the air. Somebody has to accept the electron. So who will accept the electron? A will accept the electron and convert into A 2 minus. Now if you add the equation A plus B, they will form below it as what? AB. They will form AB because two electrons will be cancelled out. Now what is reducing agent and what is oxidizing agent? If you understand, it is very simple. Oxidizing agent, which is also known as oxidant, What is oxidizing agent, beta ji? Oxidizing agent means what? देखो. Now this B is acting as an oxidizing agent. B is acting as an oxidizing agent. What happened with B? B का self oxidation happened. B का what happened? Self oxidation. B का self oxidation, right? So I will write oxidizing agent मतलब oxidizing agent. Okay, it is going to oxidize. A is going to oxidize B, right? So A is acting as an oxidizing agent मतलब self का क्या हुआ? Reduction. So if A is acting as an oxidizing agent, A has to reduce itself. A has to accept the latter. Very simple. Oxidizing agent means self-reduction. So what is reducing agent, sir? Very easy. What is reducing agent, bolo? What is reducing agent? Reducing agent, which is known as reductant. इसका क्या हो जाएगा बोलो बेटा जी? This is called as self का oxidation. Very, very easy. भूलेगा ही नहीं कभी. You will never forget. Reducing agent मतलब क्या? Reducing agent means self का oxidation. And oxidizing agent means self का reduction. As simple as that. तो कभी डाउट ही नहीं होगा. बस इतना याद रखो. Oxidizing agent means self का reduction. Reducing agent means self oxidation. You will never get confused into this. Just remember these two statements. Oxidizing agent means self ka reduction and reducing agent means self ka oxidation. For example, let us come to this question. In the case of sulfur plus oxygen, what is happening? What is oxidizing agent and what is reducing agent? Let me ask this question. You look at sulfur. Sulfur का खुद का क्या हुआ? Sulfur is getting oxidized. Sulfur का self oxidation. That means sulfur will act as a reducing agent. Oxygen. What happened with oxygen? Oxygen का self reduction because it is good. This is reduction, right? This is reduction. और ये वाला term क्या है बोलो बेटा जी? Oxidation. So sulfur is going for self oxidation. Therefore reducing agent, and oxygen is going for self का reduction. Therefore it will act as oxidizing agent. So this oxygen has acted as an oxidizing agent. Why? Because it has oxidized sulfur. So therefore oxidizing agent. This sulfur is acting as a reducing agent. Why? Because this sulfur by donation of electron has converted 0 to -2. So act as a reducing agent. Very simple, right? Just remember this one thing. Oxidizing agent means self ka reduction. Reducing agent means self-oxidation, as simple as that. Just give me a thumbs up if this concept is clear to you. Tell me. Bolo beta ji. Give me a thumbs up. Is this concept clear to everyone? Let's see. Everyone? Every one of you? Yes, clear to everyone? Very simple. Very good. So it's very, very easy. Now I'm going to ask different problems where you have to tell what is oxidizing agent and what is reducing agent. Okay. Now second reaction we have aluminium plus bromine giving AlBr3. Aluminium plus bromine giving AlBr3. Is this reaction visible to everyone? Is the reaction visible to everyone? Bolo beta ji, yes or no? Is this reaction visible to everyone? Aluminium plus Br giving, okay, visible, right? Okay. Now look at this. Aluminium having oxidation number 0. Aluminium having oxidation number 0, right? And bromine also having oxidation number 0. What happened? Aluminium gets oxidized from 0 to +3 oxidation state. This is written +3. And what happened with bromine? Bromine from 0 converts into -1. Convert into what, bolo beta ji? -1. So, what is aluminium? Aluminium is an oxidizing agent or reducing agent? What is aluminium? What is aluminium, bolo beta ji? Oxidizing agent or reducing agent? Aluminium self का oxidation. Aluminium self का oxidation. So what is happening? The thermite reaction is also yes. Aluminium is a reducing agent. Yes, because it is doing self का oxidation. Because metallurgy में most of the reactions are oxidation and reduction reactions, redox reactions. So aluminium का self oxidation, therefore it is a reducing agent. And bromine का self reduction, therefore this is acting as an oxidizing agent. What is the combination reaction? What is the combination reaction? Two elements when react with each other, combine with each other, through the process of combination, some element is losing electron, other element is gaining electron. That is called as combination redox reaction. That is called as combination redox reaction. Okay, great. Chalo, let us go to the next one. So this is the first kind of redox reaction. Second is called as decomposition redox reaction. Second is what? Decomposition redox reaction. What is happening in decomposition redox reaction? Very easy. Idhar dekho. In decomposition, mercury is in +2 and oxygen is in -2. Mercury is in +2. अच्छा, इस mercury को क्या बोलेंगे? Mercurous or mercuric. This mercury will be called as mercurous or mercuric. If you remember the nomenclature, this mercury will be known as mercurous or mercuric. Give me the value quickly. Mercurous or mercuric. अस नहीं है बेटा, अस नहीं है, इक है, इक. मर्क्यूरस कैसे हुआ? अरे HgO -2 +2. Mercury has two oxidation state. One is Hg+1 and one is Hg+2. Lower oxidation state as, lower as, higher ik, higher ik. भूल गया बेटा. This is mercuric oxide, mercuric. Anyways, so decomposition happened of this solid. If you give thoda sa temperature, decomposition will happen. Now, mercury from +2 converts into what, bolo beta ji? 0, and this -2 to 0. So basically, this is reverse of combination reaction. This is reverse of combination reaction. In case of combination reaction, what is happening? These are reacting with each other and changing the oxidation number. In this one, they are decomposing and changing the oxidation number. It should be, one should be always oxidation and one should be reduction. So that is redox. Look into this. Potassium chlorate, ClO3. Do you remember the ions ka name? We have ClO minus, ClO2 minus, ClO3 minus and ClO4 minus. Can you give me the names? Can you give me the names of all these four? We have studied the name. ClO minus, ClO2 minus, ClO3 minus and ClO4 minus. Start with this one. Start with this one. What this ion will be called as? ClO minus. Give me all these four names. hypochlorite. Very good beta ji, very very good, very very good, very good, hypochlorite. And this will be called as hypochlorite, chlorite, very good, chlorate, perchlorate, very good Srikar beta ji, very very good, hypochlorite, this is chlorite, very good beta ji, very good. So lower oxidation state का क्या बनेगा 8 और higher का क्या बनेगा 8. So this one was 8 and this one was 8. So this was chlorite and this was chlorate. And if you go below to that, that is hypo, and if you come above to that, per. Hypo, per. Caloric acid somebody is writing. Bekuf, Desmukh. Caloric acid. Okay. Decomposition reaction. So KClO3 decomposes into KCl plus O2. Right? Now, you see, chlorine ka oxidation number +5 and oxygen ka oxidation number -2. So this decomposes. Potassium ka nahi change ho raha hai. Potassium is +1. Alkali, alkaline earth metal do not change their charge. Strong metals. So chlorine from +5 to -1 and oxygen from -2 to 0. So one is oxidation, this one is what below reduction, and this one is oxidation. Right? Similarly, sodium hydride. I'll write it somewhere over here. Sodium hydride. So what is happening in sodium hydride? Dekho, what is happening in sodium hydride? Sodium hydride mein what is being formed? Sodium solid and what is formed below? Hydrogen gas. Sodium solid and hydrogen gas. Now I told you how chlorine charge is -5, sir. Chlorine is -5. Case, okay, no problem. Idhar dekho, KClO3. Look at KClO3. Potassium +1. Write the charges, beta ji, write the charges. X is the chlorine, X is chlorine. Potassium, alkali, alkaline earth metal, alkali metal +1. +1. Plus how many oxygen? 3. And what is the charge? -2 is equal to 0. X, bolo beta ji, -5 is equal to 0. So X is equal to +5. Oxidation number +5. Oxidation number +5. Okay. So sodium hydride. Sodium, if you remember, in all other cases, hydrogen has oxidation number +1, except one case when it is bonded with metal. Because metal having very very less electronegativity, because metal does not have tendency to accept, it always donates. And electronegativity concept is to accept the electron. Metal never accept, metal always donate. Electropositive, not electronegative. So whenever hydrogen is bonded with metal, it will have -1, right? So this hydrogen -1, and this sodium +1. So from +1 it goes to 0, and from -1 it goes to 0, right? So in this case what happened? What is this reaction? +1 to 0, self ka reduction. +1 to 0, reduction, very good. And -1 to 0, oxidation. -1 to 0, oxidation. I hope this is clear to everyone. Metal hydride, H is -1, very good. Zombie, very good. Okay. Let us go to the next one. Third kind of reaction, third kind of redox reaction is combustion reaction. Actually, combustion reaction is the basis of fuel cell. You know fuel cell? Fuel cell. Hydrogen, you might have studied. Hydrogen plus oxygen giving H2O, right? If you can balance the reaction. This is called as fuel cell. In this, a lot of energy is released. In this, a lot of energy is released, which is directly electrical energy. So basically this is a galvanic cell. Fuel cell is a galvanic cell. So combustion reaction, it's very very interesting. I'll tell you something about it. Before that, let us go to the reaction. So any combustion reaction is a redox reaction. Let us see. Look at this reaction. कोई सा भी हाइड्रोकार्बन ले लो. Take this hydrocarbon. Let us say methane का combustion कराओ. If you do the combustion of methane, what is the product formed in methane? Sir, will they repeat this concept again in college? Yes, they will repeat, beta ji. But if you'll understand well over here, it will become easy for you. Otherwise, the time allowed in the classrooms are very less, so it will become difficult for you. So therefore, we are doing this. So CH4 plus O2 form bolo beta ji CO2 plus H2. Forming what below? CO2 plus H2O. You can balance the reaction. So 2 plus 1, 3. You can write over here 3/2, something like that. Okay, we are having 2. So balance kar lo, whatever. So this is 2H2O. So 4, 2 plus 2, 4. Right over here. So this is 2. So 2 plus 2, 4, right? So 2 oxidation. Okay. Now this is a redox reaction. Why this is a redox reaction? You see, any combustion is redox. What is oxidation number of carbon in CH4? What is carbon oxidation number? Give me quickly. Combustion reaction. Bolo beta ji. What is the oxidation number of carbon in CH4? Give me the value, please. Oxidation number of carbon in CH4. Oxidation number of carbon in CH4. Give me the value fast, please. -4. Very good. Very good, Krishna. +4. Arey, so low, beta. How you are doing? Hydrogen is metal with hydrogen -1. Otherwise, hydrogen is always +1. Hydrogen is always +1. X -4. +4 is equal to 0. X is equal to -4. Hydrogen other than metal, whenever it is bonded, it is +1. So carbon contains -4, right? Now from -4 it is going to what oxidation number? +4. -4 से किधर गया? +4. तो क्या हो गया बोलो बेटा जी? This is oxidation, lower charge to higher charge, oxidation, right? What happened to hydrogen? Hydrogen is +1 and here also hydrogen is +1. So nothing is happening with the hydrogen. Hydrogen is okay. There is no change in charge for hydrogen. But look at the oxidation. Okay, look at the oxidation now. In the case of oxygen, what is the oxidation number? 0. We have discussed this so many times. No electronegativity difference, oxidation number 0. From 0, it is going to what, beta G? From 0, idhar kitna gaya? Idhar also we are having -2 and here also we are having -2. So oxidation, 2 moles of oxygen are there. 1 oxygen will go over here, 1 mole will go over here and 1 mole will go over here. In both cases, they are becoming -2 and -2. So how many electrons were lost? Idhar dekho, -4 to +4. How many electrons? 8 electrons. How many electrons? 8. Idhar dekho, -4 to +4. 8 electrons, right? Who is going to accept the 8 electron? 1 O2. 1 O2 accept how many electron? 4 electron. 1 O2 accept 4 electron to become what? Bolo beta ji, to become 2 O2 minus, right? So if you will take 2 moles, if you will take 2 moles of O2, how many electron will be accepted? 8 electron. How many will be accepted? 8 electron, okay? So these 8 electrons are accepted, so -2 and -2. So any combustion reaction is an oxidation, redox reaction, sorry. Come to this one, very interesting. Water ka case dekho. Look into this. What is the oxidation number of hydrogen? 0. This is combustion reaction. You are not having carbon, so only water will be formed and electrical energy will be released. Here, because we are doing a galvanic cell, if you forget about galvanic cell, forget about galvanic cell. So this is a simple combustion reaction. Simple combustion reaction. Hydrogen oxidation number 0. And what is the oxidation number here? +1. What is the oxidation number? 0. And what is the oxidation number? -2. -2. So idhar kya hua bolo beta ji? 0 to +1, what happened? Oxidation. And 0 to -2, what happened? Reduction. So any combustion reaction, it is not in my hands to conduct morning session, beta ji. We have morning classes in college. Okay, so any combustion reaction is a redox reaction. Is it clear to everyone? Combustion reaction clear to everyone? If you have any doubt, you can ask. Combustion reaction clear to everyone? Bolo beta ji, everyone, combustion reaction clear? Redox reaction it is. I hope this is clear to everyone. Bolo everyone, please. Yes, okay, thank you. Thank you. Let us come to the next one. Next type of reaction is called a displacement reaction. This you have all studied. This we have all studied, but you have studied one famous, which is called as metal displacement reaction. So I have different kinds of displacement reaction, which is very, very important. Let us go for this. So first one is hydrogen. First type of displacement reaction is hydrogen displacement reaction. Now you all know, for the displacement reaction, there is something called as activity series which is involved. There is something called as activity series which is involved, isn't it? So how can we tell that it has been reduced or gained in a reaction? Arey, half cell reaction beta ji. Hydrogen is 0, 0 se +1. 0 se +1 means what? If an atom is becoming A to A plus, that means what? It has lost 1 electron. So positive charge metal loss ho gaya. If you are having an atom B and it accept electron, तो क्या बन जाएगा? माइनस हो गया. So 0 to -1, 0 to -1 accept electron, reduction हो गया. 0 to +1 oxidation हो गया. Oxidation means what? Loss of electron. Reduction means what? Gain of electron. In the last class we have discussed all these things. Where were you, beta ji? This question is not good. Be in the class. Listen to the class carefully. So displacement reaction, hydrogen displacement reaction. Okay, what is the hydrogen displacement reaction? And this is a very, very famous experiment which most of you would have done. Can you tell me the experiment in which hydrogen displacement reaction is observed? Can you tell me any reaction? Experiment actually, which we have done in our high school in the labs. Very famous reaction in which hydrogen ka displacement happened. Can you tell me? There is a very famous experiment. Metal and acid. Very good, beta ji. Very good. What is that experiment? What is that experiment? Metals with acid. What is that experiment? How do we recognize that metal has reacted? Very easy, very easy. So batao beta ji, tell me. Metal acidity, right? How do we know? How do we know that metal has reacted with acid? From the experiment, how do you know that metal has reacted with acid? How do we know? Metal and acid, zinc HCl, very famous reaction. How do we know? एक experiment होता है ना, pop sound. Very good, Ganesh. Very good. Hydrogen gas, pop sound. Thank you so much. Thank you. Pop sound. Some of you, I think you have not done the experiment. So when a metal reacts with an acid, it liberates hydrogen gas and a pop sound comes. I don't know how many of you have done that. Pop sound reaction it is. Anyways, so whenever a metal reacts with the, जैसे मैं एक example इधर ले लेता हूँ, कोई सा भी example ले लो. Let us say Na plus water. Now Na plus water, what will happen is sodium is more reactive in comparison to H plus. So what will happen is sodium will donate the electron and H plus will accept the electron, and what will happen? Sodium खुद का क्या करेगा? Sodium will get oxidized. So from 0 this has become +1. That means what it is doing? Self ka oxidation. Therefore it is a reducing agent. Therefore it is a reducing agent, guys, and hydrogen is +1 and hydrogen becomes what? Over here. Okay, we are talking, yes. So hydrogen gas, NaOH plus H2 gas will be released, right? So hydrogen is +1, hydrogen from +1 become what? 0. So this is a reducing agent. Why? Because what is happening? Oxidation. What is happening? Oxidation. So sodium gets self-oxidized. Self-oxidation, therefore reducing agent, and water, hydrogen H plus, self का क्या किया? Reduction. Self का reduction, therefore water here will act as what, beta ji? Oxidizing agent. It will act as an oxidizing agent. So we are having so many displacement reaction. This is a confirmatory test. This is a confirmatory test for the acid. Whenever you put a metal into the acid, no matter whether a metal, no matter whether the acid is strong or weak, it doesn't matter. It will react even with the water. You see, water is not an acid. Water is not an acid, right? Is water an acid? No. But whenever there is H plus, partial charge H plus, not like strong H plus, partial plus H plus, then also metal will react and it will displace hydrogen. So this is a confirmatory test for the acid. Even weaker to weaker acids can give this test. Okay. So we are having so many reactions over here. Calcium plus 2H2O, hydrogen displacement. So all the hydrogen displacement reactions are redox reaction because metal will get oxidized. Metal will do self-oxidation. Therefore, metal will act as a reducing agent. Metal will act as a reducing agent. Now, on this basis, I have a very important this table over here. You can see this table. Is this table visible to everyone, guys? Is this table activity series table? This activity series table, is it visible to everyone? Activity series, is this visible to everyone, guys? No, not visible. Oh. Some of you are saying yes, not visible, huh? Oh, yes, some of you are saying yes, most of you are saying no. Okay, I don't know. This is the activity series which is already in your NCERT textbooks. which you are already having in your NCERT textbooks, so not a big deal, but मैं बता रहा हूँ. So lithium, you see in the alkali metals, lithium, sodium, potassium, rubidium, cesium, right? Francium is a radioactive element. So you see lithium being on the top is a very strong metal. It loses one electron and become lithium plus electron. Now, you know, if you go top to bottom, actually visible but not clear. No problem, I'll explain. Don't worry about this one. I'll explain anyway. Just listen to my concepts clearly. So as we go top to bottom, actually metallic character increases. That means the ability to donate electron increases. The ability to donate electron actually increases, right? But in this particular case, lithium acts as the strongest reducing agent. Lithium is the strongest reducing agent. Strongest. When I say it is the strongest reducing agent means what? Strongest reducing agent means self-oxidation. Strongest reducing agent means what? Self-oxidation. That means lithium can oxidize itself very, very easily. Lithium can oxidize itself. Basically, there is a concept of hydration energy. I am not going into that. For now, lithium is a very strong oxidizing agent in aqueous medium. याद रखना बेटा जी. In aqueous medium, पानी में, aqueous medium में. It is a very, very strong reducing agent. So it can easily lose the electron. So it is going for self-oxidation. So from bottom to top, reducing strength increases. Just remember, reducing strength means what? Reducing agent ka strength. How to know that? Self-oxidation should be high. Self-oxidation should be high. So these are all the metals. These are all the metals which are losing electrons. That means they are doing self-oxidation. They are doing what, Bulbeta ji? Self-oxidation. Because they are doing self-oxidation, they will act as reducing agent. So top to bottom, reducing strength ka character decreases. Bottom to top, it increases. Now, this is very, very interesting. You see, I'll write the metals over here. So lithium, potassium, barium, calcium, and sodium. These are all alkali and alkaline earth metals. So alkali, alkaline earth metals are generally highly reactive, which are on the top side, of the periodic table. Electropositivity means what? Metals are electropositive. That means they like to donate electron and become positive. In terms of electronic thing, it will become positive. So donates electron and become positive. Electropositive. Metals are electropositive. Donating electron and becoming positive. Okay. So these metals are highly reactive. Highly reactive in terms means it can easily donate electron. It can easily donate electron and become plus. Become what, Bulbeta ji? Plus. They can easily become plus. Therefore, they are a very good reducing agent. Therefore, these are all very good reducing agent. That means they will react with the cold water. Because they are so reactive, they will react with the cold water. They will react with the cold water. Right? Because they are so reactive, they will react with the cold water. After that, we are having magnesium, aluminium, zinc, chromium, iron, and then we are having cadmium. So these are not as strong as these metals. They are not as strong as these metals, but they are also strong. They are also strong. That means they are also having good tendency to donate electron. That means self-oxidation. That means they will act as reducing agent. बात समझ आ रही है? So therefore they will react with the steam. Steam. That means very, very hot water. That means it has been converted into steam. Vapor के form में आ गया है. So they will react with the steam. If you go down, you look at this blue one. ये blue वाले को देखो बेटा जी. In this blue one, we are having hydrogen. So hydrogen converts into H plus, right? Now, if you go below that, copper converts to Cu2 plus. Now, this is very interesting. You see, hydrogen goes to, bolo beta ji, hydrogen goes to H plus plus electron. So 2H plus. So how many electron? 2 electron. And copper goes to Cu2 plus 2 electron. Now, you see what will happen? Hydrogen is above in the table. Hydrogen is above in the table. That means it can easily lose the electron in comparison to the copper. That means hydrogen is a better reducing agent in comparison to the water. Hydrogen is a better reducing agent in comparison to the copper, right? That means if I write the reaction Cu plus water, are we going to expect the product? No, product will not be formed. Why product is not formed, sir? Because copper ka activity, or you can say reducing nature, reducing strength is less than hydrogen. So H plus will not convert into hydrogen, because actually hydrogen can lose H plus rather than copper. Hydrogen can lose H plus, right? It is not going to accept the electron because it is having more ability to donate rather than accept in comparison to the copper. Is it clear to everyone? So whatever comes below this, whatever comes below hydrogen, everything is not going to react. So what are the elements? Copper, silver, gold, platinum and mercury. Copper, silver, gold, platinum and mercury, they are having less reducing nature in comparison to the hydrogen. They are having less reducing nature or reducing strength in comparison to the hydrogen. Therefore, it is not going to react with the water. Therefore, it is not going to react with the water. Is it clear to everyone? This activity series. So, whatever element is above, for example, let us say we are having zinc and we are having copper, which we have already studied, right? Zinc and copper. So, zinc comes above in the table. Therefore, beta ji, therefore, zinc can reduce ZnCuSO4, ZnSO4 plus copper. Because zinc ka reducing strength is more. Reducing ability of zinc is more than copper. Therefore, it can reduce Cu2 plus into copper. So anything what lies below in the table, they can be reduced in comparison to the higher ones. Is it clear to everyone? Just give me a thumbs up. Is this clear to everyone? This activity series ka concept, is it clear to everyone? Bolo beta ji. Let's see. Copper less reactive than zinc. Actually, this table, no beta ji, this will be explained. This table is based on electrochemical series. This is also called as electrochemical series. There is a chapter in 12th class which is known as electrochemistry. So this will be explained why lithium has a strong reducing nature. It will be explained in the electrochemistry chapter. Lithium plus has very high hydration energy. So everything will be explained. Don't worry. Everything will be explained. Why activity series is like this only. You know, it will be explained. Will hydrogen displace copper sulfate? See, hydrogen can replace copper sulfate. Might be possible. Might happen, but we generally don't see that reaction, but it may happen, beta ji. Not a big deal. It might be possible. Sulfuric acid will be formed along with the copper. Sulfuric acid will be formed along with the copper. Okay. Okay. Chalo. So, next one is halogen displacement. Next, first displacement we have studied is hydrogen displacement. Now we are starting halogen displacement. What is halogen displacement? ध्यान से देखना बेटा जी. All halogens will accept electron and convert themselves into X minus. All halogens accept electron and convert themselves into X minus. Why is that, sir? Because we know halogens, fluorine, chlorine, bromine, iodine, they lies in the right side of the periodic table. Right side of the periodic table. Because they are in the right side of the periodic table, their electronegativity is very high. Their electronegativity is very high. So they are more susceptible to accept the electron. Therefore, they are more susceptible to accept the electron. Now, if I'll ask you, beta ji, ki in F2, Cl2, Br2, I2, as we go top to bottom in the periodic table, what do you think? As we go top to bottom in the periodic table, electronegativity increases or decreases? Bolo beta ji. As we go top to bottom in the periodic table, electronegativity decreases or increases? Bolo, increases or decreases? As we go top to bottom in the periodic table, electronegativity increases or decreases? Decreases. Who is saying increases? Arey, Chaitanya Reddy beta ji. Noble gas also participate in reactions beta ji. That is different concept. We are not going into that. Decreases, right? Arey, decrease karta hai bhai. I have explained this concept. Left to right in the periodic table increases. Top to bottom decreases. So, which can easily accept electron, which have more electronegativity. Therefore, fluorine will easily convert into F minus. Therefore, fluorine will easily convert into F minus in comparison to the chlorine. And chlorine will easily convert into Cl minus in comparison to what? In comparison to bromine. I think all of you understood, a very easy concept, right? So, bromine will accept 2 electrons and convert into Br minus. Similarly, iodine will accept 2 electrons and convert into 2 moles of I minus, whatever, balance kar lena. So, which is easy to accept electron? For which halogen? Fluorine, right? For which it is most difficult, iodine. Now, if I have a reaction, idhar dekho, Cl2 plus I am having Br minus. Cl2 plus Br minus, NaBr, KBr, anything like that. Cation has nothing to do with the reaction. Na plus will be there, it doesn't matter, K plus or Na plus. Cl2 plus Br minus. Sir, is it going to displace Br minus? Is it going to displace Br minus and form Br2? So we are having an ionic compound K plus Br minus. Is it going to displace Br minus? Answer is yes. Why answer is yes? Just now I told you कि Cl2 का ability to accept electron is more because electronegativity is high. So in this case what will happen? Cl2 will try to convert itself into Cl minus because in comparison to the bromine it is more capable to accept the electron, right? So this will become what? Cl minus, and Br minus will become what below? Br2. So Cl2 to Cl minus, 0 to minus 1, 0 to minus 1. So this is called as what below? Reduction. And because it is doing self ka reduction, therefore Cl2 here is known as self ka reduction, therefore Cl2 known as oxidizing agent. Br minus convert from minus 1 to 0. So self का क्या हुआ? Self का क्या हुआ बोलो? Oxidation. Therefore it will act as reducing agent, right? Very good. Similarly, if I'll ask you, let us say we are having Cl2 and F minus, NaF. Now the product form will be, बोलो बेटा जी, F2 plus NaCl. You can balance the reaction. इसको कर दो 2 और इधर हो जाएगा F2 and this is 2 NaCl. Is this reaction feasible or non-feasible? Reaction is feasible or non-feasible? बोलो बेटा जी. Is this reaction feasible or non-feasible? Reaction feasible or non-feasible? बोलो. Cl2 plus NaF reaction feasible or non-feasible? Non-feasible. Very, very good. Nirati, very good beta ji. Non-feasible. Feasible means whether it will happen or not. Reaction will take place or not. That's all. Non-feasible. It is not feasible, right? Very good. Very good. Because we know that fluorine wants to convert into F minus. It wants to gain electron, not to lose electron. I'll ask one more question and I'll close the class. So let us say we are having Br2 plus NaCl. And then we are having, let us say, what I should take. Let us say we are having NaI plus Br2. Okay. Now, the question is, in this case, the product should be, what should be the product? NaBr plus Cl2. And in this case, the product should be, bolo beta ji, NaBr plus I2. Let us call this as reaction 1 and reaction 2. Tell me which one is feasible and which one is non-feasible. Give me the answer, let us close the class. This is non-feasible, right? Because fluorine will not convert into F2. As we have seen, the activity is more for F2, Cl2, Br2 and I2. Tell me, let us say this is one, non-feasible and feasible. Very good, beta ji, very good. Very good, Tulsi, Krishna, very good, beta ji, very, very good. Very good. First one is feasible. First one is feasible. Seriously? First one is feasible. First one is non-feasible and second one is feasible. Very good, beta ji. Very good. First is non-feasible, yaar. Kaise feasible hai, beta? First one is non-feasible. No. Br2 and Cl2, which will be easily formed. We are having Cl minus 1. Now, bromine, does it having enough capacity to take the minus charge? No. Because Cl is more electronegative, it will not allow the bromine to take the negative charge. So this reaction is not possible, and here bromine is more electronegative in comparison to I minus, therefore this will become Br minus 1 and iodine will be 0. So this one is feasible. Is it clear to everyone? Just give me a thumbs up. Let's close the class. Tomorrow we'll continue. So we are done. The last reaction is left, disproportionation. Then we have question to solve tomorrow, and then we will learn tomorrow balancing of redox reaction. Tomorrow we will learn balancing of redox reaction. Is it clear to everyone? Just give a thumbs up. Let's close the class now. Thank you so much, everyone. Thank you. First one is non-feasible, second is feasible. Right. Thank you so much. Thank you, everyone. See you tomorrow. Thank you.